And now for our friends from Red Hat. How are you?
Yeah, but that I'm really well. Thank you very much. How are you doing?
I'm good. Where are you physically? Where are you located?
I'm in Stockholm, Sweden.
Just was there. Had a wonderful time there. It was great.
Okay,
Um,
I hope you are here for the 30 degrees Celsius. Wonderful.
no, it was what I got caught up in was all the traffic there. There's so much building going on.
Yeah, there is. Yeah, certainly.
So introduce yourself so people know who you are.
Sure. So I'm CMX Againfor. I'm one of the product managers at Red Hat for OpenShift. I drive continuous delivery products and some of our initiatives about around developer experience.
Yeah, Nexus, Sonatype, and Red Hat work a lot together.
Correct. Yeah, we're partners, especially around OpenShift. We have multiple of the products running, and we've done quite a number of joint efforts actually around it. So it's quite a long relationship. We also look forward to continue and evolve.
Right. I see the name of the session here. Let me read it here just to make sure I've got it. Cloud Native CI/CD with OpenShift and Tekton. Give us an overview. What's going to happen here?
Sure. So CI/CD is nothing new, really, but people have become quite comfortable adopting a lot of these practices. It started really a couple of years back with with containers taking off, and Jenkins has been really the king of CI/CD, right. Most widely used. But there have been challenges also around it. So it's still love and hate relationship around Jenkins. And I want to give an update of what's happening in the community around what people are looking forward as the next step, based on the lessons learned from Jenkins and going towards something that addresses some of those challenges that Jenkins has within Kubernetes landscape, within the container landscape.
All right, you just said the magic word, Kubernetes. You know, everybody.
Yeah.
Let's see. Let's get your screen share going. I'll make sure it's happening before I step back.
Sure. Okay.
There we go. And full screen. If you change to the next slide, I can verify it's working okay for you. There you go. I'm going to disappear, but I'm here if you need anything.
Sure. Thank you. All right, folks, let's get started. So I want to talk to you about Cloud Native CI/CD with Tekton. It's the name of an upstream project. I'm going to explain a little bit, and specifically on OpenShift, the Kubernetes distro from Red Hat, what we're doing about it, what kind of problems we're solving with that for users. But before that, we can't talk about CI/CD or any CI-related topic without Jenkins. Jenkins is really the most widely adopted CI engine around for developer for applications. It has really grown into a tool that is used for a large number of purposes, to be frank. CI/CD is one of them. I've seen many of the ops-related tasks that people use to orchestrate shell script execution, a lot of other things like that. It has huge number of plugins. It's a plus for that. It can, for always, whatever you want to do, you can always a plugin that does that for you. So it's a lovely piece of software. The problem with it is that it was designed way before the container environments come along. Containers they weren't popular really. They didn't exist. The technology existed at the time that Jenkins got lifted off the ground, but they weren't popular the way they are now. Docker wasn't a thing. Kubernetes certainly wasn't. So bringing that Jenkins love to the container environment, it had proved to be challenging, not as lovely as it used to be in pre-container environments. So the first thing is that Jenkins itself is not built for container environments. It's a monolith. Everything is one piece of monolith. But it's also not really built for container applications. So when you have container applications, you generally have different pieces of it built by different teams. This is regardless of if you're doing microservices or not, but especially more visible when people build microservices applications. There are several different teams. They all own different pieces of the software. They want to go toward DevOps practices, own more areas, more stages in the lifecycle of their services. So they want to own some of those pipelines that help them to test the software, test their service, maybe deploy it also into production. However, Jenkins doesn't really support this model because of the centralized model that it has. So what customers do, what users generally do, there is a team that is kind of a center of excellence around Jenkins. So you want a change in your pipeline, you want a new plugin, you got to go ask them. And guess what? There are another 200 plugins, another 200 pipelines running on the same Jenkins instances. So they install a plugin, you ask, the whole thing blows up. Jenkins server is down for half a day, nothing is getting built, nobody dares to commit. The mess just gets bigger and bigger because of that centralized model that is not really seen with the way that we build apps today for cloud native apps. Plugins, I said it's a huge plus that you can find a plugin for everything, but at the same time, if you just started with Jenkins and you just want the basic flow to get going, it's quite confusing to know what plugins you have to use. For everything, there's at least 5 plugins that do the exact same thing. It's difficult to find your way around it. And Jenkins server itself, it needs a lot of babysitting. You have to really take care of it for it to keep running. It's quite common that we see among customers that people restart Jenkins server once a day to just start fresh in the beginning of the day and have it working throughout the day. So it has been difficult. And every time I talk to someone at a conference or at a customer meeting or someone at the events, when Jenkins comes up, they always tell me a new story of how they love Jenkins and how they hate it at the same time because of some of the issues that they run into. So that really started off to the community to think about, all right, so Jenkins is great, but what would be next? So if the landscape has changed, if the way we build software has changed, if the type of software we build has changed, we're building more for the cloud environment, does that have any consequences for the way we do continuous delivery and continuous integration? And guess what? It actually does. But before that, let me define what cloud native CI/CD means. With cloud native is quite an overloaded term. So I want to let you know specifically what I mean when I say cloud native CI/CD. There are a couple of characteristics that we mean, that we expect from a continuous delivery provide a solution or framework that we call cloud native. The first one is that it is container-based. It itself is container-based, it's built for container environment, but also for apps that run in containers. So we want to go away from that centralized model, babysitting model. The second thing is that it's got to be serverless. We have seen this model from many of the cloud-based, SaaS-based CI solutions like Travis and Circle CI and so on. That you don't really take care of any CI engine in that sense. You just say, this is my pipeline, often defined in a YAML file. Just go run it, instantiate it every time there's a change in your code or config or in that Git repo. It just runs it, execute it, give you the result. There is no server to take care of. And that's also one of the characteristics. We just want to run CI/CD. We don't want a CI/CD server to take care of. And the last piece is that it got to be adapted to DevOps way of working. Cross-functional teams, distributed teams, decentralized teams should be able to own their piece of software, their pipeline, the plugin related to that, the life cycle of their software through this pipeline. They should be able to own it without interfering with other teams, without creating problems and blocking other teams from using the same type of pipelines. So that's really a setting. That's what we are aiming for. We look for a cloud native CI/CD solution that is built for Kubernetes and container environment. But something really good happened a couple of months back, and that was the birth of the Tekton project. Tekton is an upstream project, an open source project that is aiming to provide the building blocks, the plumbing, a set of standard terminology and also standard Kubernetes objects, the custom resources that we call on Kubernetes or CRDs, to help build standard CI/CD systems on Kubernetes. And it was donated to the CD Foundation that was also recently formed about the same time. It was announced at slightly before KubeCon, so that the governance model is with a lot of vendors that have a lot of experience around CI/CD. Bring that experience, build something that is standard for Kubernetes. We have a lot of contributions from Google, RedHat, CloudBees, IBM, Pivotal, and many more. It's a super popular project in GitHub. More than 2,000 stars last I checked. And in itself, it's really born out of the Knative project that you might have heard of. Knative is a set of serverless constructs for Kubernetes. And they first identified a need to build functions and containers from source. And it immediately turned into larger requirements that, well, we need to really think about the more complex workflows of taking source code and convert it to the piece of application or function running on Kubernetes. So that's where Tekton really came along to address those cloud native concerns that we have around CI/CD on Kubernetes platforms. And what we're doing at Red Hat is to bring that and enrich it with an experience around it as OpenShift Pipelines that provides a cloud native CI/CD experience on OpenShift based on Tekton. The value of it is that it's a standard construct. So when you build a pipeline using OpenShift Pipeline, you're essentially using Tekton CRDs, Tekton constructs, and you can take those pipeline definition, go to another Kubernetes platform, install Tekton, and run them as well, or create another pipeline, just move it from the other platform to OpenShift. It gives you that portability because of this standardization that Tekton provides. It defines also the terminology. It becomes really simple to communicate between different projects because I'm going to get to some of those constructs that are defined in Tekton, but it gives you a common set of terms and definitions for how you define these pipelines. Every platform so far has defined their own. So some platforms, some solutions, they have pipelines and jobs and steps. Sometimes they have only jobs and resources and steps. Sometimes they have jobs and tasks. So every solution has been using some other terminology, and Tekton has standardized that so they can use that across platforms. It also runs everything in containers. So any pipeline that you're on essentially breaks it down into smaller pieces, and every piece is a separate container, which makes it really easy to scale. So you want to run a lot of pipelines at the same time. They're essentially just more pods, more container running on Kubernetes. You take advantage of Kubernetes capabilities for scaling your infrastructure, the capacity that you have for running pipelines. It gives a really powerful CLI command, Tekton CLI. It is heavily being worked on now. This is a very active project. So every week you see new commands added. That makes it like a really brief and nice to work with the pipelines. And another area that I'm really thrilled about, that it really opens up the door for using a variety of Kubernetes tools for building images. Building images is generally difficult. If you go down the Docker file path, it has its own challenges. There are other tools around like source to image on OpenShift, or Canico from Google, or Jip, or BuildPack. There are many ways to build container images, and each of them has some advantages, some disadvantages, fit some of the cases, some don't. And what OpenShift Pipeline with Tekton allows us to do is really opens the door to that extensibility. You pick any of these build tools that you need for a certain project, just hook it into the pipelines and use it for a certain pipeline. In another pipeline, you might use S2I. For another one, you might use Canico, and so on. That said, all of this is designed for Kubernetes, but that doesn't mean as the target platform. So from a pipeline that is running on OpenShift or Kubernetes, you can, of course, deploy to any of the target platform. You can deploy function on a serverless platform, or you can deploy to a VM or Kubernetes or OpenShift. So you're not really bound with the target platform. It's just itself that is designed for Kubernetes and runs efficiently on Kubernetes. And last but not least, we were trying to really integrate that experience around Tekton. So Tekton just provides the plumbing, the bare bone. We're building the UI on top of that, enrich the CLI, bring plugins around that in VS Code, in Eclipse Chair, really make it easy for a developer or an SRE engineer to be able to use this pipeline throughout the different tools and get information about it right from the tools or IDE that they are used to working with. But what are these standard constructs? I mentioned a couple of times that Tekton defines the standard terminology and construct for defining pipeline. There are a few of them that I'm going to run through to just give you an idea how a pipeline is constructed when you're building through OpenShift pipelines with the Tekton terminology, Tekton CRDs. And each of these is a CRD, a custom resource on Kubernetes. So there are standard resources that I can move around between Kubernetes distros. The first one, the very smallest unit of work, is called a step. Step is a command that you run in a container. You say, this is my image, and run this command inside it to perform a certain task. It is the container spec in Kubernetes, so you can define everything like volumes or envars or config maps or secrets. You have access to the entire Kubernetes within that container spec. So it's really simple to, for example, in the image on the slide, you can see a step that is defining to run a package goal for a project based on a Maven image from Docker Hub. So that image would be downloaded, a container would be spin up by OpenShift Pipelines, run the Maven package command in that, and when it finishes, it just removes that container. The next construct is called task. So step is not really a CRD, it's just a small piece of another CRD. Task is the first custom resource defined by Tekton, and task is a number of steps. You say, I have these 4 steps, and they run in order, they run sequentially. So the first one container comes up, runs the command defined on that task, and that step. Then the second one comes up, and the third one, the fourth one, in order. One finishes, and then the next one starts. And all of them are running in separate containers, but within the same pod, within the same task pod. That has a couple of advantages for us. The first one is that because they're all running in the same pod, so they have access to the same storage and volume. So they can share files with each other. They have access to the same network. They're as if they're running on the same host, really. But at the same time, they're running in different containers, so it's really easy to scale each of the steps separately, and it gives us a way to have deterministic order in the way that we want the commands to run. You can put them in the same task. It's guaranteed that they all run in the same order. So even though the steps are within the same pod, but when you have multiple tasks, each task will be a separate pod and might end up on a separate node in Kubernetes. The next CRD, which is really the heart of Tekton, is called pipeline. And pipeline is a combination of the tasks that you define. You connect the tasks. So these are the tasks that I want to run. Each task has a number of steps. And you can define a certain order in some of the tasks to form a graph. So you can say this task should run after the other one, or this task requires an input from this other task. So you might run a task that is a Maven package that produces a jar file. You want to give that as input to the next task that is a source to image for building an image from that jar file. So you can define this relationship between the tasks, which essentially forms a graph between those tasks. And like I said, tasks can run each task runs in a pod, separate pod, so they might end up on different nodes, something that you need to keep in mind. The next CRD is pipeline resources. So in Tekton, there is a decoupling between inputs and outputs to the pipeline. A pipeline resource defines the inputs to both tasks and pipelines, and then outputs. And when I say to pipeline, you define an input to the pipeline, and pipeline would pass it on to the tasks that are defined in pipeline. The same way works for the output. An input to a pipeline or task is a Git repo. You say, I want to take the code and configuration from this Git repo and then run through the steps defined, right? And through the tasks defined in my pipeline. Output might be a file on a storage block, or it might be an image that you push in a registry. And the good thing about pipeline resources is that they're decoupled. So you can define a Git resource and then reuse it across multiple pipelines. If it's the same Git repo that are using multiple pipelines, maybe one for the dev cycle and another one for testing, you use the exact same resource. So you have reusability. It makes it really simple to use the same resource across multiple pipelines. And all of that is to the definition side. So now we come to runtime, and we want to run a pipeline. There are two constructs, two CRDs that define that. The first one is a task run, which represents a task executing. So even though Tekton is for building pipeline, you can also just take a single task, that Maven package task, for example, and run that separately. You create a task run that will run the task for you. And there's a pipeline, which represents the runtime status of the pipeline. And this decoupling really comes handy in this scenario, because pipeline run is the one that defines the relationship with pipeline and pipeline resources. So you want to pipeline itself, it doesn't know from which Git repo have to take the code, or into which registry has to push the image. Pipeline resource knows that and defines that. So in the pipeline run, you connect the pipeline to the resource. You say, run this pipeline that builds the application and builds the image, but take the source code from this pipeline resource and the result should be pushed to this pipeline resource. So it gives you a level of reusability. Why is this useful? I can take the same pipeline and run it across and run it from, I can take the same pipeline and run for multiple source code repos. So maybe I have forked the Git repo of our application on my personal account. I can just create a new pipeline resource for my own Git repo, my fork repo, and pass that to the pipeline run to run the exact same pipeline that runs for production, for deploying to production, based on my fork repo. The same for images. I want to take the same pipeline, but push to my own personal software and use it with our own fork Git repos or our personal registry accounts, so that we can run the exact same pipeline that runs in different environment, but with our own code and images. It's really useful and makes it easy to reuse both pipeline and also resources.
So you've got about 6 minutes to close up. You good?
Sure. So how do we put all of this together? So far, I've defined how do you define each of the CRDs. You basically define a pipeline. You define the tasks that are in that pipeline. You form your graph, take the source code, build a jar file, build the image, run a test, whatever your tasks are. Then you create instances of pipeline around that really triggers that pipeline. Execute it, you connect it, you say which pipeline, which resources. Those are the Tekton and the extension control that run that. And Tekton spins off pods to run that pipeline for you. So the controllers are themselves pods running on Kubernetes, and everything else that you define in a pipeline also runs in a pipeline and scales on demand, and as you run more and more pipelines. How does that come together as OpenShift Pipeline? So OpenShift Pipeline brings in Tekton as the basis of the plumbing of the CI/CD, and we add an experience on it. The first thing we have added is an operator to make it really simple to install Tekton on OpenShift. So you go to, I'll show you in a second, to a place with a list of a catalog of the operator. You choose OpenShift Pipelines, you install it, and it enables Tekton on the system. We are adding also a set of extensions and integration and tasks to make it simple, so you have more building blocks to build your pipelines. Common tasks are maybe you want to build an image from your source code using S2I. So we provide a number of reusable tasks, so you don't have to create those tasks. You can just compose your pipeline through those existing tasks. And higher on the upper part, we also work on a set of developer tools that make it easy to interact with this pipeline. The first one is Tekton CLI. We're putting a lot of work upstream to launch Tekton CLI as the first tool to interact with the pipelines, but also VS Code plugin or Eclipse Shape plugin, and bring a UI on top of that, so you have a full spectrum of different tools and availability of pipeline within the IDEs that you work with, so that you can easily interact with these pipelines connected to your code. And this is the one that I was referring to. So this UI is OpenShift Web Console, OpenShift 4. Operator Hub is the place that the operators are listed, or operator is how a piece of software is installed on Kubernetes. To the right side, in the middle, you can see OpenShift Pipelines operator. That when you install that on the platform, it will enable Tekton CRD, so you can immediately start creating pipeline CRD. Or if you just go to the Tekton GitHub upstream repo, there are examples there that you can download and directly run it on the platform, because all the Tekton CRDs would be enabled on OpenShift. If you want to try out pipelines today, there is a tutorial available on GitHub. I'm going to give you, I'm going to open it up so you can take a look at that quickly. It walks you through how you can get access to an OpenShift 4 cluster, and it walks you through a number of steps, so you can define the concepts and how you can create a sample pipeline on OpenShift using OpenShift Pipeline, using Tekton CRDs, and get your feet really wet and get some experience with it. That said, Tekton project is quite young. It is just born out of Knative project like 2 to 3 months ago, but there is a huge interest around it. We look for a lot of feedback. We look for people who try it out. We know that a lot of people are interested as we talk with them. If you're interested, come to the GitHub project, reach out to us with question. I'm going to be also on the Slack if you have more question. We are really thrilled about the project upstream, and this is really a good possibility, good opportunity for us across the industry to come to the standard way of building CI/CD pipelines of Kubernetes that was not possible before because of all the variations and so on. And with that, I'm going to conclude this session. Thank you all for joining the session today.
Hey, thank you so much. Always good to hear from you and see what you guys are doing and the support that you're giving us too in the community. So you're going to head over to the Slack channel and answer questions for anybody who has questions there?
Sure, I'll do that.
All right.
I'll check the Slack
I
right
will
away.
see you over there. Thanks.
Thanks. Take care.